In this lesson, we're going to continue our study on multiplying radical expressions. Before we do that, let's remind ourselves about this idea. So if I have, let's say, 2x times 3x plus 4, remember I have this monomial factor times this binomial. So to get rid of this parentheses, and I am multiplying because this does say 2x times this factor here, I can distribute. So for this part, I'm going to use the distributive property. So 2x times 3x is 6x squared, and then 2x times 4 is 8x. And then you would combine like terms if you could, and in this case, you cannot. The other thing you learned was that, well, if you have something like 3x minus 5 times 2x plus 3, then in this case you're multiplying two binomials, and you could use the distributive property. You'd say this term times this binomial, and then minus this times this binomial. But most students just go ahead and notice, hey, since these are two binomials that I'm multiplying together, then I can just use the FOIL method. And then you can. So 3x times 2x is 6x squared. The outer is 9x, and the inner is a negative 10x. And the last is negative 5 times 3 is a negative 15. I can combine like terms here. So I can combine these x terms. And so I get 6x squared minus x minus 15. Okay? Now, what we're going to do, though, is we're going to use these ideas with radical expressions. So let's look at number one. So number one, so the directions will say multiply. Now, just keep in mind that when you're multiplying rational expressions, you want to make sure that you just don't multiply. You have to make sure that your radicals are simplified as well. Okay, so just note that part of multiplying these radical expressions is to simplify. So number one, let's suppose we had the square root of 3 times the square root of 3 minus the square root of 15. Okay, so here I have this monomial factor times this binomial, so I can distribute. So using distributive property, I have the square root of 3 times the square root of 3, and most of you know right away that the square root of 3 times the square root of 3 is just 3. Now, you can, I'm going to go ahead and write this work for right now, but I'm not always going to do this. So I would just want you to know that this right here means the square root of 3 times the square root of 3. All right, minus, and then the square root of 3 times the square root of 15. So each of those terms are being multiplied by the square root of 3, and that's what you see here. Then you use some information that you learned in the past. Well, the square root of 3 times the square root of 3, I can write this as one radical. That's the square root of 9, but many of you knew that that was 3. And then over here, so remember the indices are the same. So square root of 3 and square root of 15 is just the square root of, and then 15 times 3 is, what's that, 45? So I get 3 minus the square root of 45, okay? Now, what you got to do now is make sure that this is as simplified as you can get. And it's not, because notice, remember the largest perfect square that goes into 45, because it's a square root, the largest perfect square that goes into 45 is 9. So in my mind, I know that the square root of 45 is equal to the square root of 9 times the square root of 5. And then the square root of 9 is 3, so you get 3 square root of 5. And so your answer then would just be 3 minus 3 square root of 5. And that's all that is, okay? So it's a lot of things that you've learned in the past that you use here. And number two, let's suppose in number two I had the square root of 3 times 8 square root of 2 minus 8 square root of 25. So okay, so in this case, I would just go ahead and use that same approach for right now. So I would say, well, that's going to be the square root of 3 times this, so times 8 square root of 2, minus, and then the square root of 3 times this, square root of 3 times 8 square root of 25, okay? And then I know, so if I cover this part up, then I know from previous lessons that I can rewrite this as the square root of 3 times square root of 2 is the square root of 6. So I get 8 square root of 6. So this is 8 square root of 6. Now be careful here. So you may say, well, I'm going to go ahead and say 3 times 25 is 75. Yes, you can. You can definitely do that. but then you'd have to simplify the square root of 75. So I want you to see this before I tell you what you should notice. So the square root of 3 times square root of 75, I'm sorry, square root of 3 times square root of 25 is square root of 75, and the largest perfect square that goes in 75 is 25. But I want you to notice, so that's 25 times 3, but I want you to notice that you're doing too much work there because this is this. So what you want to notice is that, well, you can automatically say that the square root of 25, this right here, is just 5. And so 8 times 5 is 40. So you get this right here is 8 square root of 6 minus, and then 8 times 5 is 40. So you get 40 square root of 3. So minus 40 square root of 3. And those are not like terms. Remember, like when dealing with radicals, like terms have to have the same indices, and they do, square root, but the radicands are different. All right, so there's the answer there. Okay, number 3. So let's suppose in number 3, I have the square root of 13 plus 3 times the square root of 2 minus 5. So this time I am multiplying two binomials together. So two factors with two terms. And so I can use a fall method. So the square root of 3 times the square root of 2. So remember what I'm saying is this. So, I'm sorry, square root of 13. Square root of 13 times the square root of 2. So if you need to write out this step, do that. So the square root of 3 times the square root of 2. So that's my first. The outer will be minus 5 square root of 13. That's the outer. The inner would be plus 3 square root of 2. And the last, I'm going to just go ahead and write this as 3 times negative 5 is negative 15. Now I got to come in here and simplify as much of this as possible. So I can rewrite this. I can simplify this. That is the square root of 26. And there's no perfect square other than one that is divisible into 26. So that's all I can do here is leave it like this. And then I'm going to go ahead and rewrite all this over. 5 square root of 13 plus 3 square root of 2 minus 15. And none of these terms are like terms. So that's your answer. All right, number 4. So let's number 4. So number 4, let's suppose we had this. Number 4, let's suppose we had 6 square root of 3 minus 3 square root of 5 times 4 square root of 3 plus the square root of 5. All right, so let's suppose we had that. All right, so again, I have two factors with two terms, so I can use the fall method. Now, be careful. So try not to do too much in your head if you feel you're not going to be careful. So you have this times this. I'm going to go ahead and rewrite it. So 6 square root of 3 times 4 square root of 3. So that's first. The outer. So again, be careful. The outer is 6 square root of 3 times the square root of 5. Okay. The inner is minus 3 square root of 5 times 4 square root of 3. Okay, that's the inner. And then the last, a negative times a positive is a negative. So I get it minus 3 square root of 5 times the square root of 5. Okay, so first, outer, inner, last. All right. Okay, now let's go ahead and simplify this. So let's remember, cover all of this up if you need to. So just look at this part for right now. 6 times 4 is 24, so you get 24. The square root of 3 times the square root of 3 is the square root of 9, which most of you know is 3. All of you know is 3, right? So you could have just written 3 here. Okay, so basically this becomes 24 times 3. Okay, times, don't forget that's multiplication. All right, then we go to the next term. So we took care of this one. Now let's go to this one. So again, if you have to cover up, stuff that's gonna probably throw you off, then cover it up. So this, the square root of 3 times the square root of 5, that's square root of 15. So I can't do anything with the square root of 15 in terms of simplifying. So I'm going to just go ahead and rewrite this. I'm going to go ahead and do that here. It'll be plus 6 square root of 15. Okay, so that's this, and then that's this. Okay, and I'm going to come here, cover this part up if you have to, and then cover this part up if you have to. So you have 3 times 4 is 12. So I do this right here becomes minus 12 square root of it, then 5 times 3 is 15. So that part is going to come here. So minus 12 square root of 15. I cannot simplify the square root of 15. The only perfect square that goes in 15 is 1. And then finally over here, right here, so that's going to be right here. That's going to be minus 3 square root of 25. But we know that that's 5, right? Square root of 25 is 5. So that becomes minus 3 times 5. Okay? So again, this part here is this. This is 6 square root of 15. This is minus 12 square root of 15. And this is minus 3 square root of 25. And the square root of 25 is just 5. Okay, simplifying this, 24. And again, if you need to use your calculator, use your calculator. So 24 times 3, let's see, that's going to give us 72. And then plus, now I can combine these right here, right? Because those are like terms. I have square root, the radicands are the same. So 6 square root of 15, subtract 12 square root of 15 is a negative, I'm going to go ahead and write it like this, minus 6 square root of 15. And then minus, and this is 15, okay? Now let's combine like terms because I can still combine like terms because notice that you have a constant and a constant. So 72 minus 15 gives us 57. So that becomes 57 minus 6 square root of 15. And there's your answer there. So notice the work that was involved. So quite a bit of work there that you had to do. All right, let's look at number 5. So number 5, let's suppose you had, let's look at this one. So let's suppose we had 7 square root of 2 minus 4 square root of 3 times 7 square root of 2 plus the square root of 3. All right, so same approach. So again, if you have to do each part individually, like we did here, then go ahead and do that. So first times first. So I have 7 square root of 2 times 7 square root of 2, right? The outer, I have a positive times positive is a positive. So 7 square root of 2 times the square root of 3. The inner, a negative times a positive is a negative. So we're subtracting. 4 square root of 3 times 7 square root of 2, right? And then the last, so minus 4 square root of 3 times the square root of 3. Okay? All right, now let's again cover up things that you need to cover up. So we have 7 times 7 is 49. And then what you know is the square root of 2 times the square root of 2 is just 2, right? Square root of 4, which is just 2. Okay, let's look at the next one. So again, cover up stuff you need to. So then we're going to have plus, right here, plus. All right, we have 7, and then the square root of 2 times the square root of 3 is the square root of 6. Okay, so that takes care of that one. So then let's look at the next one. So we have minus, okay, 4 times 7 is 28. And then the square root of 2 times the square root of 3 is the square root of 6. And then we have minus 4 times the square root of 3 times the square root of 3 is the square root of 9, right? Square root of 9. And the square root of 9 is 3. Okay? So then I have 49 times 2, which is 98. Again, I can combine these. 7 square root of 6 minus 28 square root of 6 is a negative 21 square root of 6. And then minus 12, and then 98 minus 12, I can combine those. Those are constants. So I get 86 minus 21 square root of 6. All right, so that's number 5. Okay. All right, let's look at number 6. So let's suppose in number 6 we had this. So we have 2 plus 3 square root of 7 squared. So again, just remember what this means. So this means 2 plus 3 square root of 7 times itself. That's what that means. So write it like this. And now you use the fall method. So 2 times 2, 2 times 2, and you could have said 4, by the way. So that's your first. The outer would be 2 times 3 square root of 7. The inner would be 3 square root of 7 times 2. And then the last, always be careful with when you have two radicals involved. So you have 3 square root of 7 times this 3 square root of 7. Okay, so all I did was I did first, outer, inner, last. 2 times 2 is 4. That part's easy. Over here, that's easy as well. 2 times 3 is 6. I get 6 square root of 7. This part is easy as well. 3 times 2 is 6. I get 6 square root of 7. And I want to remind you something. So remember when you square binomials in a previous course and also in this course, when you square binomials, see when those two binomials are the same, the outer and the inner are going to be the same. So notice those are the same. All right, and then 3 times 3 is 9. And then the square root of 7 to the square root of 7 is the square root of 49, right? And the square root of 49 is 7. So that's 9 times 7. So now I get 4 plus 6 square root of 7 plus another 6 square root of 7 is 12 square root of 7. 9 times 7 is 63. And so 4 plus 63 is 67. So you get 67 plus 12 square root of 7. All right, so it's number 6. Let's look at number 7. Suppose we had this one for number 7. 5 square root of 2 minus 3 square root of 7 squared. So 5 square root of 2 minus 3 square root of 7 squared. Same thing. Do the same thing. So we're gonna write out what this means. So when I'm squaring a binomial, so I'm gonna rewrite this as 5 square root of 2 minus 3 square root of 7 times itself. Okay. And then I'm gonna use the fall method. First times first, the outer, the inner, and then the last. Okay? And write it out. So I have 5 square root of 2 times this 5 square root of 2. Write it out. Okay, now the outer. A positive times a negative, so there's going to be subtraction here. So 5 square root of 2 times 3 square root of 7. Now the inner. A negative times a positive is a negative, so another subtraction. So 3 square root of 7 times 5 square root of 2. And now the last, now be careful, a negative times a negative is a positive. So notice I'm going to put a positive here, and I'm running out of room here. Yep, running out of room, so put it right underneath here. So 3 square root of 7 times 3 square root of 7. Okay, so remember, negative times a negative is a positive. All right, now let's go ahead and simplify as much of this as possible. So again, look at this part first. 5 times 5 is 25, times the square root of 2 times the square root of 2 is the square root of 4, which is 2. Okay, minus 5 times 3 is 15. The square root of 2 times the square root of 7 is the square root of 49, square root of 14, and I cannot simplify the square root of 14. The next one, 3 times 5 is 15, and square root of 2 times square root of 7 is the square root of 40, square root of 14. And again, notice, remember, these are the same binomials, right? So the outer and the inner should be the same, and they are. See, they're both the same. And then 3 times 3 is 9, and square root of 7 is the square root of 49, which is 7. And so now I get 50. 25 times 3 is 50. A negative 15 square root of 4, negative 15 square root of 14, another negative 15 square root of 14, those are like terms, gives me a negative 30 square root of 14. And then 9 times 7 is 63. And then 50 plus 63, what's that? That gives us 113. Is that correct? All right. And then minus 30 square root of 14. And so there's the answer there. Okay. So that's number 7. Now what I want to do is kind of look at a few now, a couple with variables in it. So let's look at number 8. Number 8. So number 8, let's suppose we had negative 3 square root of a times the square root of 2b plus 4 square root of b. Okay, so let's suppose we had that. Okay, so again, I'm going to use, now here you have one factor times a binomial. So let's go ahead and use the distributive property. So write it out first. Just say, well, that's going to be negative 3 square root of a times the square root of 2b, just like that. And then plus a negative 3 square root of a times 4 square root of b. Okay? And so now remember, I can, since the indices are the same, I can multiply the radicands together. So it becomes negative 3 square root of 2ab. That's what this is. And then that will be minus 3 times 4 is 12. So we minus 12 square root of, and then a times b is ab. Now be careful. Some students are going to want to combine these. These are not like terms. See, the radicand here is 2ab. This is just ab. All right, so there's nothing you can do there. So in terms of simplifying. So there's your answer. Okay, that's all you do. All right, let's get number 9. Number 9, let's suppose you had negative square root of x times the square root of x minus 3 square root of y. All right, so let's suppose we had that. All right, so again, using distributive property, so I get negative square root of x, this times this. So negative square root of x and square root of x. Now notice a negative times a negative is a positive. And then square root of x times 3 square root of y. I want you to remember that the square root of x and square root of x, let me go ahead and write it underneath. Square root of x and square root of x, y'all agree with square root of x squared, right? Because x times x is x squared. And then over here, plus, and then you're multiplying two square roots. Notice the indices are the same, so just multiply the radicands together. So it becomes 3 square root of x, y. Now you got to simplify if you can. And I want you to remember that you can simplify the square root of x squared. What times itself is x squared? Well, that's just x. Remember 2 divided by 2? All right, so negative x plus, and you can't do anything with this, with the square root of xy. You cannot simplify that because notice the exponent here is 1, the exponent here is 1, and that's less than the index. And so there's your answer. That's all you do. All right, let's do one more. Let's try this one, number 10. So let's suppose we had, actually we'll do 2 more. So let's suppose we had 9 square root of x times 8 square root of 5 minus 4 square root of x. And so using distributive property, I'm going to get, and again, write it out if you have to. So it becomes 9 square root of x times 8 square root of 5, right? This one says. And then a positive times a negative is a negative. So 9 square root of x times 4 square root of x. And so 9 times 8 was that 72? And then the square root of x and the square root of 5, that's just the square root of 5x. So when the indices are the same, you multiply the radicands. And then minus 9 times 4 is 36. And then the square root of x times the square root of x is the square root of x squared. But remember, the square root of x squared is just x. And I cannot simplify the square root of 5x, so that becomes 72 square root of 5x minus 36 times x. All right, and you cannot simplify anything else. You're done. Okay, finally, number 11. So I want you to know that all the problems we've done had dealt with square roots. We go back, everything with square roots. So let's do one where it's a cube root, just to see what's involved there. So let's suppose I had the cube root of 6 times the cube root of 3 minus the cube root of 12. Okay? So let's suppose we had that. So again, you're going to use the distributive property and write it out if you have to. So you have this cube root of 6 times the cube root of 3. Okay, this times this. Minus, and then the cube root of 6 times the cube root of 12. Now remember, when you're multiplying radicals and the indices are the same, and they are, you can multiply the radicands together. So this becomes the cube root of 18. 6 times 3 is 18. Minus, and 6 times 12, and so when you multiply 6 and 12, because the indices are the same, you're going to get this cube root of 72. All right, now don't stop there, because you got to ask yourself, can I simplify the cube root of 18 and can I simplify the cube root of 72? So is there a perfect cube other than 1 that goes into 18? So remember, your perfect cubes are 1. The next one is 8. 8 is 18 divisible by 8? No. The next one is 3 cubed is 27, so that's too big. So that cannot be simplified. Now look at this one. 1's a perfect cube. It goes in all of them. So don't use 1. Go find another one if you can. The next perfect cube is 8. Is 72 divisible by 8? The answer is yes. Okay, because remember the cube root of 72 is now going to be the cube root of 8 times the cube root of 9. And remember, the cube root of 8 is 2, because 2 times 2 times 2 is 8. So you get 2 cube root of 9. And that's what this becomes. So this becomes the cube root of 18 minus 2 cube root of 9. And there's your answer. Okay? All right, so that is lesson on multiplying radicals. And remember, when we did this, we involved distributive property, and we also used FOIL. Okay, so this is our lesson on multiplying radical expressions.